This is MATD1544. We're busy sketching the graphs for rational functions, and this morning we're going to look at the slant or skew or oblique asymptote. All these words are used, so I've just put them there for you to see the different words that they use for for this kind of asymptote, and it's just that you will recognize if they use one of these words. Okay, so remember now, a rational function always have a vertical asymptote because it is division, and then the denominator cannot be 0. So therefore, they all have vertical asymptotes. So if we have a function like here, P over Q, when Q is 0, we must have a vertical asymptote there. And a graph can never cross the vertical asymptote. Okay. But now we have done the horizontal asymptote. So a rational function either has horizontal asymptote or a horizontal asymptote, or a skew or slant or oblique asymptote. Okay. And when will it have a skew? Here it is indicated the skew one over here. Remember that it can cross here, it can go through the skew asymptote, but not at infinity, because that is actually where it exists. Because remember, we said that the horizontal and the skew asymptote is at the limit to infinity, where x approaches infinity of the function. So it happens here right at the ends. Alright, and when will we have a skew asymptote? We will have it when the degree of the top is more than the degree of the bottom. So the degree of the numerator is higher than the degree of the denominator. We called it top heavy. So when the function is top heavy, then we will have a slant or skew asymptote. So if we look at this example C in your books, we can clearly see that the power there's 2, or the exponent. So the leading term has degree 2. The leading term of the denominator has degree 1, which is lower. Therefore, it's top heavy. Therefore, we're going to have we'll definitely have a vertical asymptote, but I mean, therefore, we were going to have a slant asymptote and no horizontal asymptote. So all the other steps stay exactly the same. We will factorize, we will find the x-intercepts, we will find the y-intercept by making x 0. The vertical asymptote when the bottom is 0, just like we've done it. But now when we get to the step of horizontal or slant, we see top heavy. As we just said, the degree is more, so there is now a slant asymptote. Now to determine the slant asymptote, excuse me, we have more than one method, and you can choose which one you like most and which one you want to use. It doesn't matter at all. So when we determine the slant asymptote, we need to divide this x minus 2 in other words, we actually make an improper fraction. We basically make an improper fraction, which we can see here. So we divide the x minus 2 into the top, and then we see that part there, because if we do now the limit to infinity, then this part will go to 0, because infinity underneath will make it 0. So this part will go to 0, and basically the quotient there, the quotient here, will form the slant asymptote. So basically we divide with long division. If you can use synthetic division, you can use that, but you need to know your slant asymptotes here, because Yes, your long division here, I mean, you need to know your long division here, because sometimes we cannot do the synthetic division and so on. Okay, I was just thinking exactly what I must say here for you, because there's a couple of things that's important. Okay, there's also an alternative method. So I'm going to also just go through the alternative method, and then if we draw the graph, we can look then at both. So the alternative method is that we know that this slant asymptote is going to be a straight line. It is going to be a straight line, and therefore we know a straight line is mx plus c. So is there a way that we can determine the gradient and maybe the y-intercept, because that is the m and the c, and then find the horizontal, this is not the horizontal asymptote, it's the slant asymptote. You must just correct this for me, please. This should be the slant asymptote. In class we did correct it, but those of you that's at your homes because of the COVID, please just change that, and you're watching this video, just change that to slant asymptote. It should be slant, not horizontal here. Alright, so it is a straight line, and there is a way that we can find m. And we can find m by doing the limit to infinity of f over x. So basically we divide f by x and then find the limit to infinity. Then we will have m. Then we use this m here. Just be very careful there that you understand this very well, but otherwise you're going to mess this up now. This m that you have calculated here, you're going to use here. So whatever it is there, you're going to use here. So to find your c, your y-intercept, you're always going to take your f minus, and then you're going to use that m. So your f minus the m that you got there, x. F minus mx, work that out, and then find the limit to infinity of that. That will give you your c value. And therefore you will then have the horizontal asymptote. So if we can come back here, and we just try that now. So in other words, we said, listen, we can find m by doing the limit to infinity. And we've done limit, so this is now not a problem for us, of the f function over x. So basically you just multiply the bottom by x. So you get x squared minus 2x. Now if you have to find this limit, it's very easy now, because we know now that the degree is the same here for the top and the bottom. So it will be the leading divided by the leading, so we're going to have 1. So just remember that it is a straight line, and you are calculating m here. Alright, so now we want to find the c. Here we got minus 1 for the c value, mx, 1x, so that's the same now, and then minus 1 is the c here. So the c we find by doing the limit where x approaches infinity, okay, of f minus, so f, the whole of f, and we can add fractions. That's why we did a whole section on that, a whole unit on that last semester, so that this is not a problem for us. We did a whole unit on adding and subtracting fractions. So remember, it's mx. I just want to emphasize that it's not x. Some people think, it's x, but remember it's mx, because I write here x, and then they think it's x, but here mx is only x, because m is 1. So we're going to find the limit to infinity of this. This will be the limit where x approaches infinity, and then we're going to find x squared minus 3x minus 4 over everything is going to be over x minus 2, of course, because we're making a common multiple. And then we're going to have minus x squared, and then of course plus 2x. So now what will happen is the x squareds will fall away. So this power will be falling away. And now we see here we have minus 3x and plus 2x. And that's going to give us the minus x. And then we have x underneath. So that's where the minus 1 is going to come from. So let us just finish it off. So this gives us now the limit where x approaches infinity. And then we have the minus x minus 4 over x minus 2. Now we know how to do the limit to infinity. And we also know now a bit more. We know that it forms a pattern. And if the degrees are the same, we can just take the leading coefficient over the leading coefficient. So this is negative 1. So therefore C is negative 1. And therefore we now have the same slant asymptote of y is x minus 1 that we found by doing the long division. So this is the alternative method of finding the slant asymptote. It really doesn't matter which method you people are using. That's your choice. I just like to give the alternative because if you make a mistake in your long division, you know, then the whole thing is wrong. Yeah, I just feel we've done the whole unit on limits to infinity, so this should not be a problem. And we've done adding and subtracting fractions, so also that should not be a problem. So to me it just makes sense to look at this alternative method, and at least then you have a backup just to check your answers, because if your slant asymptote is going to be wrong in your graph, the whole graph is actually going to be wrong. Okay, so maybe we can just go over now. You've got the book with the examples fully out there, but maybe we can just done for you, I mean, so you can go look over that by yourselves. But let us maybe just do an example together. Yeah, let's do this number 4 together, which is top heavy, and therefore it is going to be a slant asymptote. Alright, so we can factorize. Remember that the question will be sketch the graph of, and we see now that this is a rational function, and then everything should click, hop in, and all the skills and everything that you must do should just be there for you. So we factorize, and remember, it's not always going to have factors at the top. Don't get into that habit. It can be that you need to use the formula to find these x-intercepts, because it's not always going to be 100% factors every time, and so on and so on and so on. So if that can't be factorized, we will just use the formula, because this is just quadratic. So we will just use the formula to find the x-intercepts. Okay, so the x-intercepts is where the top is 0. And that will give us 3 or minus 1. 3 or minus 1. The y-intercept is making x 0. So that's going to give us y is minus 3 over 2. Minus 3 over 2. And now, the vertical asymptote, because this is a rational function, it must have a vertical asymptote. That is where the bottom is 0. And now, I must decide. And I see this is top heavy, so there's no horizontal asymptote. There's going to be a slant asymptote. There's going to be a slant asymptote. And now I can decide which method I'm going to use to find this slant asymptote. So I'm going to use the alternative one. The other one is just long division. Okay, so my gradient will be the limit to infinity of f over x. Basically multiply the bottom by x. Okay, and that gives us 1. Okay, now my c will be the limit to infinity of f minus mx. Remember, it's mx. This is again 1, so then don't get confused and think it's always minus x. It happened before, and that's why I'm emphasizing it now, that you realize it's not minus x, it's minus mx. So I'm going to write 1x here, that we just don't get confused by that. Okay, so this is going to give me x squared. Sorry, let me just get the limit again there, because we haven't taken the limit yet, so the limit must still be there. So it's the limit where x approaches infinity, and then it's going to be x squared minus 2x minus 3 minus x squared minus 2x, it looks like. Yes, over x plus 2. Once again, the square term is going to fall away, and it's going to be the limit where x approaches infinity of minus 2x and minus 2x. It looks like minus 4x, and we have minus 3 over x plus 2. So this gives minus 4. So remember to just answer the question. So therefore, the slant asymptote. Don't stop here now. You never answered the question. Remember, the question is you must get the slant asymptote. Or, if you just stop here, you didn't indicate what is the slant asymptote now. So we want to see that it is y is equal to, because it's a straight line, and it's x minus 4. Okay, now you can go, this is not minus x now, there's a little, let me just take that, it's just x minus 4. Okay, let me just write that it's clear. Okay, so now we still do our number line to find where the graph is going to be. This is very important, because we still need to show where is it going to be above the x-axis, where is it going to be below the x-axis, etc. So that it just makes it easier for us to draw. Now remember, we put the boundary points here, which is the x-intercepts as well as the vertical asymptote, the restrictions. So if I look, I see it's minus 2. Minus 2 is not included because that forms that vertical asymptote. So here is a vertical asymptote. Okay, and then at minus 1, we're going to have an x-intercept. That means it goes through the x-axis there. And at 3, we're going to have another x-intercept. That means it goes through the x-axis there. So check every region. In this case, it is positive, negative, positive, negative. And then go plan now and with your table mode that I always use, we talked about that now often. I still do that. I prefer to do that. So yeah, go make sure that you understand how to use the table mode on your calculator to help you to see what is going on here. Sorry, I just want this. See, I don't know if I'm going to get it back now because I actually want to move this. Okay, but it's not going to help me now. Oh, I've got it back. I just want to move it out of the way here. I didn't want to have it between the graph. Okay, that's better. So let us just plan our x-intercepts and everything here. So here we have now the minus 2. Let's see, let's say it's about here, minus 2. That's going to be a vertical asymptote. Okay, so that's giving me x equals minus 2. Let's label that everybody knows what we are doing. And then we have an x-intercept at -1 and at 3. X-intercepts at -1 and at 3. We have a y-intercept at -1.5. Round about here, -3/2. An a y-intercept. And then we have this slant asymptote now at which is x minus 4. So it's going to go through -4 here and at 4 over there. Alright, so we need to draw that asymptote. Now I'm going to just draw it here, see how good I can get it right with this application. Sometimes it's a bit of a struggle, but please do it with broken lines. Maybe I think it's just going to be better. I'm just going to click on it again and just try to see if I can extend it, if I can get it right. Just to extend it for us here. Looks like it's going to work. Okay, and remember now to also, when you draw, do your vertical asymptote, bring it down, properly, that you can see what is possible, what can happen, and so on. Okay, so now we go to our number line and we see what is happening here. So it tells us here that when we are to the left of -2, we're always negative. Okay, and then there's an asymptote that we must bounce over, and then our graph must go through the -1 on the x-axis. So that shows us then that it looks to me, and I can look on my table mode to see if my values agrees, but it looks like this graph is going to bend like that here, so that it can stay negative forever, and it must approach now this slant asymptote, and it must approach this vertical asymptote, and then it's bouncing over. And then it's going to go through my x-intercept here. It's going to go through my y-intercept there. Turn, go through the x-intercept again. And approaching this slant asymptote. Okay. And then you can see also the form of the hyperbola, because after all, this is a hyperbola. So just check now on your number line that everything agrees. So if you said it's negative between -1 and 3, make sure that it is negative now between -1 and 3. That it does go through your y-intercept. That it is approaching your asymptotes like you have said that they are asymptotes. Because if you say it's an asymptote, it must approach that graph. Okay, so I think if you understand what to do, and it's not really that difficult. I just want to emphasize again, on Mondays and Fridays at 8 o'clock, we will join, and you are welcome to load into your Jamboards, and then we can look at it, because on this Mondays and Thursday, Friday mornings at 8 o'clock, then I can look at your graph. So you can try another graph, and you can upload it there, and I can look at it then on this at 8 o'clock, because this is our meeting time, and we can look at that. But this concludes then how to draw the rational functions. We have looked at those with horizontal asymptotes, and this is then how we tackle the slant asymptote.